basis of differentiation. And about this example here, a cardboard of size 12 by 12 is cut at 4 of its corners such that equal squares of sides y centimeter by y centimeter are cut at each corner. The sides are folded to make an open box. We are to find y so that the volume of the box is maximum. From what we've discussed on maximum and minimum differentiation, we said at the point of maximum, the y dx is always equal to 0. So we can write from there and say our solution to this, to find the minimum value or the maximum value. I told you to find the maximum value. So from what we've discussed, maximum value is just a point at which I can write maximum value. At maximum, we say the y dx is equal to 0. Now, to carefully understand this, we can try and draw out the cardboard, which is basically going to be in form of a square. Diagram not done to scale. Students should know that. So now, what we're trying to say here is that we have a cardboard. Initially, the dimension was given to be 12 centimeter by 12. Then each of the corners are now cut out like this to form a square, to form an open box. So these are the corners that was cut out. Just want us to see that. And the dimension of each of the corner was given, as we all can see, as y by y centimeter. So we can just go like that. I hope students understand this y by y. So to get the remaining dimension, just follow your mathematics knowledge of mensuration. So if everything from here to here is 12, here is y, here is y. Everybody should know that that's y plus y is 2y. So the L dimension here is 12. The remaining dimension will be 12 minus 2y. I hope students understand this. So that will also opens to this side, because we're talking about 12 minus 2. So now, when it was cut, it's now forming an open box. Open box can be in any form. You can just visualize one diagram not drawn to scale. So we can say the open box is more or less a box like this. After it was cut out, we're having something like this. So we say we join this together. So we have this as well, just for you to understand better. Bring this also to this, and this remaining corners can also be joined. So actually say we have something like an open box of diameter. So students, the dimensions are now 12 minus 2y, and this is also 12 minus 2y. Remember, the height will remain y, because you are now having something like a cube. So getting the values, the volume is what we want to work on. The volume of an open box should be length times breadth times height. I hope students still remember this formula from the mensuration class. So the length and breadth are equal. So you say V is equals to 12 minus 2y all square multiplied by y. So at maximum, already discussed, when we differentiate volume here with respect to y, it must give us 0. So we say the V divided by dy must be equals to 0. So next point, we differentiate. Therefore, a quick one, remember this product rule. I'll take U, I'll take as V. A small logic from our basis class, we keep the first one the way it is. So we say y. When we differentiate this, we're going to have, using the chain rule, this is 2 open bracket 12 minus 2y multiplied by negative 2. I hope students still remember all this basic law. Then we take the second one the way it is, 12 minus 2y all square. We differentiate y, we have 1. Everything here must be equal to 0. So I hope students understand. I can just make this and do something like, okay, fine. This is our 2y and minus 2. Why can't I say negative 4, 12 minus 2y? Close the big bracket. I move this to the other side because this times 1 is this is equals to negative 12 minus 2y whole squared. So one of this, we take care of one of these. So I think I'm having something like fine. We should have something like negative 4 is equals to, let's expand this because of error, negative 12 plus 2y. So we can collect like terms to get the answer. So we can say negative 4 plus, this is 12 is equals to 2y. So here we can say 8 is equals to 2y, and y value will be equals to 4. So I hope we didn't make mistake here. We can check it again. So here, oh, there's a mistake because this is having y. This should be 4y. That should have made us clear the question. So here, we need to just understand that we have a mistake from here. So I'll finalize an answer to know the right answer from here. Collect like terms. You can say negative 4y. Then here you have minus 2y equals to negative 12. So negative 6y equals to negative 12. So negative take care of negative, y will be 12 divided by 6. So answer is equals to 2. So dear student, that is the solution to that. And that is where I'm going to stop on my basis of differentiation. Hope to see you guys soon on the basis of integration before we go to vector. So bye for now. Do have a wonderful time. So at y equals to 2, the value of this will be maximum. You can cross-check by differentiating it again and see if it is going to give you negative. So actually know that it is maximum. Bye.